Good morning, everyone. This is Module 3 titled Motion in 2 or 3 Dimensions. But this one focuses more on the 2 dimensions. And you'll know why, Kay. So let's go. So sa kaninga picture, makita nato na motorcyclist na nag-launch ang iyang self padulong from here. Go to my pen. So from here, from here to here. Isa rin siya ka motorcyclist. It's like multiple shots. Multiple shots na siya. So, ni-launch siya at an angle like this. So, it doesn't lie on the X or Y axis alone, but rather, na siya'y duha ka axis ang gidaganan, which is two-dimensional. Two-dimensional, so na siya'y vertical launch o horizontal na motion. Okay, so this is an example of an object or tawag nato sa iya projectile. This is the projectile moving in 2 dimensions. While this one, this imaginary path or invisible line is what we call the trajectory. Ang path na giagian sa imong projectile. Like for this case, ang motorcyclist. So we can actually model this one into vectors. So we're using arrows as representation sa mga vectors. So kaning black na, let me change into kaning black na line inisiya is the trajectory niya. Ilapas tama na gani. So trajectory na siya niya. While ang kani siyang mga arrows, choose, let's choose dark blue na lang. Kani siyang blue arrow, this is the vector na component nimo or vector form niya. So it's moving in angle, then suddenly ni flat siya nga ni sa top. Kaya of course pag reach nimo sa top, wala na siya velocity along the y-axis. So mainly horizontal na kan siya at this particular top. So may bawa nimo maximum na siya if ang maximum height na siya if na-reach niya ang velocity y equal to 0. Then as it goes down, you see ang vy now generate na siya because pababa na pud. So or this vy is actually negative siya na value kay paubos man niyang direction. So here you have the same point, same sila actually og vy, galing lang ang vy na initial is going upward while ang vy na final is going downward, hence ang negative niya. And ang assumption po diri is ang acceleration along x is 0, meaning constant. So ang imo v naught x or ang vx nimo will be the same, equal to v naught x, okay, at all points class. Of course there are some conditions, like ang condition nga ni kay gineglect ang air resistance to be able to do that one. So as it goes further down, you have the same na vx. Ang by here, if mula pa siya sa level sa imo starting position, mulahi po ang value niya. Okay, only this at this point ang ka-level niya na ang vy nimo is the same in magnitude but opposite in direction. Okay, and here are some terms. Let me clear this one again. So kani siya, ang length niya from here to here is ang range. Okay, range na siya. This one is of course the height. Okay, what else? Here's the height niya. If assuming na symmetrical na parabolaan shape sa imo gidaganan or niya trajectory. Another parameter here or physical quantity here is gravity. This is the acceleration due to gravity and it's pointed downwards. Gravity niya. Okay? So, you will use this to, I hope this one helps you sa pag-visualize sa kaning imaginary path. So, you can imagine na ang kaning point here is the motorcycle. Okay, these are the same na projectile. Okay. So, as it moves, amaya behavior, maya Vy, maya Vx, maya V, when it reaches the top, mo zero niya vertical na component na velocity Vy. So, it's just along the x. Along the x na gid siya. So, okay. Let's go. So, sa motion along the x-axis, we have ax equal to 0, meaning constant ang imo velocity. So, v naught is equal to v. So, if that is 0, if we go back sa equation of motion, the first equation, this term here becomes 0. Ikaduha na equation, as isra siya. Ang third na equation, this also becomes 0 in siya na parameter. And also this one. Okay. So, kanisha is actually the same with this one. Okay. Ma-reduce the siya. Okay. V squared transpose nimo. V naught squared. And you take the square root of both sides. And of course, it gives you V naught. Okay. So, something to remember. Oh, here is a much detailed. So, ma-reduce na to an ini na mga equations further into these two equations. These are now the equations along the x component niya. Ha? So, Vx equal to V naught x minus x naught is equal to Vx, which is equal to V naught x times t. So, these are the equations left here. So, actually, acceleration here is 0, 0. Okay. So, okay. Let's go to the equations of motion along y. So, we showed this one earlier sa module 2. So, ang acceleration mo, we just simply replace it by g, which is equal to negative 9.8 meter per second squared. O ang x nato, gipampulihan nato into y, ang x naught into y naught. So, mo na siya. So, we keep the functions. Ang kuan lang, kanay isang ani is that one parameter, g, is treated as a constant. Treated as a constant. Okay, g is value 9.8. Unless ang problem ni mo class is ibutang sa lahi na planet, then you're asked to find the acceleration due to g, then you have to assume g as an unknown variable. For that particular scenario, kung sa lahi na planeta, okay, as you know, kung naka sa Earth, this is the approximation na 9.8 ang value. Pero pag naka sa Moon, it's probably lesser or sa other na mga planets. Okay. Keep that in mind. So, here are the equations ginagamit sa projectile motion. You have sa x components and sa y components nimo. So, these are the equations. Again, we still use ang Pythagorean expression to find the magnitude and the direction theta. So, basically, 1, 2, 3, 4, 5, 6, 7, 8 ka-equations ay mo i-familiarize. Okay? Let's move. Okay. What are other expressions na pwede nimo magamit? So, if you have like a symmetrical shape na trajectory, you can directly use this expression here for the height. For the height, this one, the height niya, maximum height niya. And for the range na expression, you can use this one. Okay, this is more of a shortcut, pero I think mas maayo pa siya i-derive, which is not that hard. Okay? Let's look at here an example. A bullet is fired horizontally with initial velocity of 255 meter per second. The gun is 1.5 meters above the ground. How long is the bullet in the air? That's for letter A. For letter B, if the rifle is tilted 10 degrees with respect to the horizontal, I think this is like clockwise or counterclockwise. What is the maximum height reached by the bullet? So, maximum height, so meaning pataas. So, may missing any problem. It should be counterclockwise po siya. Just to show. Oh, baligtad. Did I made a mistake? Let me go back. Okay. So, it's above ground. Okay, it's above ground there. So, this is the ground. The rifle is tilted at 10 degrees with respect to the horizontal. Okay. So, the problem is not counterclockwise, but clockwise. Pababa siya. Oh, is it pababa? Pataas siya. Sorry. Sorry guys. Sakto na yung assumption kay pataas siya. But that's for letter B. For letter A, it's this one. So, flat lang siya, gilaunch siya horizontally with an initial velocity of 255 meters per second. So, we can analyze unsay mga physical parameters na dira. So, we will set the point of release as the origin. So, at the origin, na kay x naught, y naught equal to 0. Okay? So, given magina at the origin 0, 0. Then, ang ihapod initial velocity along the y is 0 kay dili man siya pasaka. Okay? Di siya pasaka. It's just purely horizontal. Let me change. Yeah, purely horizontal yung motion. So this means imong v naught is also your v naught x. Kung ang assumption po nato ani we follow sa equations of motion na walay resistance, so that means it's also equal to vx at all points. Vx nimo same as sila tanan. Vx. Okay? So, how long ang pangutana? So, here, as it lands, you have this horizontal na velocity, Vx. And obviously, it's the same with the V naught x. V naught x basically. Napod siya Vy. Okay, patagak naman siya, which is unknown. This is Vy. O ang height niya na kay 1.5 meters na height. Negative kay pababa man siya. Ang x niya would refer to this one. So, what nakabalo? Unsa kalayo na siya. Okay? So, ang question is, how long? Okay. So, let's look at the equations available. At the x component, at the y component. So, comparing the given parameter and compare with the equation above to solve for the equation no. So, you can see here, we have this equation given na to Vx or V naught x is the same. X minus x naught, we don't have this. So, next one is ang Vy ni mo is equal to V naught y plus t. Kani siya ang unknown, we need the unknown. However, we don't know pilang Vy. We have this y minus y naught, ang height. Vy, again, we don't have this. Here, we have this. Oh, looks like we have a candidate here. We have the height. We have the initial v naught y. We have the unknown. And we have equation 6. However, equation 6, we don't know ang Vy. Let's see. So, indeed, we used ang kaning equation. I think this one is the fifth na equation. So, we're using the fifth na equation. So, y minus y naught v naught yt plus 1/2 gt squared. So, we know na ang initial position niya y naught is 0. Ang final height niya is 1.5 meters and it is negative kay paubos man siya. Ang v naught y, we know na 0 ang iyang vertical motion at the starting point kay purely horizontal naman ang pag-launch. And we have the g, which is given as negative 9.8 meter per second squared. Then ang unknown t squared. So that means this one is cancelled out and we are left with this expression here. So we can cancel the negatives. And we are left with 1.5 meters times 2 cross nato dire ang 1/2. Then divided by cross natin ni siya paubos 9.8. So it's like this expression. So ang gihimo ba na okay wa pa na i-cancel ang mga negative, but in about the later part we can cancel out the negatives here. So we're left with this equation 2 times 1.5 divided by 9.8. 2 times 1.5. This gives you 3 meter, then 9.8 meter per second squared. So this is around 0.3. Cancel a meter, 6 seconds squared. And you take the square root of that one. And should give you 0.56 seconds. Sorry, check po sa calcio. Okay. Kalisod ba ni? Okay. The next one is wait, is it? Oh yeah. The next one, so letter B, if the rifle is tilted 10 degrees with respect to the horizontal. So 10 degrees ni siya. Pasaka. Hence 10 degrees with respect to the horizontal. What is the maximum height reach? Maximum height reach. So meaning ipangita ang H nimo. Ang H nimo. So since ang shape niya is parabola, symmetrical na parabolic na shape, so we can use this equation here. H is equal to negative v naught y squared over 2g. Okay? Can use that equation. So substituting, ay mo v naught y squared is equal to v naught sine theta naught. Why is that? Okay? Let's look at the shape of this one. What is v naught y? Okay. So angle nimo theta naught. So to obtain that expression, so we use sine sa sukatowa. Sine theta naught is equal to the opposite, which is animo v naught y over the hypotenuse v. So go there. V naught y is equal to v sine theta naught. Okay? So mo na siya ang naa diri. Okay. So negative v naught y squared. So we square this expression and divided by 2g. Given man ang v naught, ang initial velocity 255 meter per second, ang angle na 10 degrees, so sine 10 degrees. Again, do not forget to change the mode sa inyong calculator to degree, divided by 2 times negative 9.8. Okay, so the negative cancels out and you are left with this expression here. Oh, very large, 19,060 divided by 19.6, and it's around this number, 100.04 meters. This is with respect to the point or release. Okay, 100 meters kapin. Okay, now let's look at the another physical quantity, ang average and instantaneous velocity. So what are they? So in the figure, you have three-dimensional axis. You have x, y, and z. So at point 1, this is some point in space at a time t1. Okay. Time t1. And you have another point p2 at the time t2. Okay. This vector r1 describes that position with respect to the origin, that initial position, and r2 describes the position from the origin of the coordinate system. So assuming na siya mga kani siya ang kaning path ang trajectory sa imong object, dili siya kanang straight lang but rather it's curvy siya. So we need to determine ang iya average na velocity. Kaya di man siya straight, average lang na velocity. So ang instantaneous velocity is given as a function of change in position over change in time. Kung imo siyang i-convert into a derivative function, kay we're trying to measure incrementally small steps, small motion, ang instantaneous velocity is a function of dx dt, a derivative function of x with respect to dt. So essentially, ang derivatives are like the change in x here. This one is the change in t. Sorry. Change in t. Okay. So very incremental. So ang average velocity, as what we solved earlier, is simply the sum of two velocities divided by 2. Kung duwa siya ka points. That is the average velocity. Okay. To help us better, let's look at this example. So you have a particle has a position velocity given by this r function. So ang iya function for the position is given as a vector sum of two axes, I hat and j hat. So 30t function siya I hat plus 40t minus 5t squared j hat, where r is in meter and t is in seconds. Letter A, find the instantaneous velocity. So instantaneous velocity, if you remember, v instantaneous is just the derivative function dx over dt as a function of t. Letter B, find the instantaneous acceleration vector as a function of time t. Okay, so I will let you guess later, or no, actually I will show you later. Okay, I'll show later on sa ang derivative function for the instantaneous acceleration. Here it is. Diba? So for letter A, find the instantaneous velocity, we use this dx dt. So the x here refers to a position r, dr dt. So muna siya. So we know that ang position niya r is equal to 30t I hat. Sorry, dapat lang siya I hat. Plus 40t minus 5t squared j hat. Okay. So we take the derivative of that one with respect to time. So here, ma-derive siya with respect to time. So matanggal ang t because derivative of 30t with respect to t is just 30. Plus, of course, this one ma-derive siya. 40t becomes 40. And 5t squared. So you bring down the exponential, multiply that one by the value here 5. So 5 times 2 becomes 10. This one ma-minusan isa. So 10t dakan. So this is the expression for the instantaneous velocity. How about sa letter B? Find the instantaneous acceleration. So if you remember, ang acceleration is just the change in velocity over change in time. So this can be if ipa-reach nimo siya ang change in delta t approaching 0, pagamay nimo, this becomes dv dt. So hence mo ni siya class. So dv dt. So what is dv dt? Ooh, nice ayup. So this one should be dv, not dr. This is dv instantaneous. So dv dt, and we can use this function kaganina instantaneous, so we take the derivative of that one with respect to time. So 30, take note, what na siya t parameter. So clearly mas zero na silang tanan. This cancels out, and this one t simply becomes 1. So may mo siya instantaneous velocity, instantaneous acceleration is negative 10 j half. Okay, by simply deriving. Oh, we have another example. So a particle moves in an xy plane with constant acceleration. At time t equal to 0, the particle is at x equal to 4 meters, y is equal to 3 meters. The acceleration is given by the vector a 4 meter per second squared I hat, 3 meter per second squared j hat. Okay, the velocity vector initially is at 2 meter per second I hat minus 9 meter per second j hat. Find the velocity at t equal to 2 seconds and find the position vector at t equal to 4 seconds. Give the magnitude and direction. Okay, let's go. From the problem, we get the following values. Okay, ang at t naught sa starting point niya 0, we already know, we're just given sa position niya x naught of y naught. 4 meters and 3 meters for x naught and y naught respectively. But we can convert this one into a vector na form. So we know r naught now is equal to 4 meter I hat along the x-axis plus 3 meters j hat along the y-axis. So this is the form niya that we created. So we now have r naught, v naught, and a, and initial time 0. So from a, we have 2 seconds with v as the unknown, velocity final unknown. So from b, we have the time t 4 seconds na with r as the unknown. Let's go. So same ra gyapon class, even though in vector sum siya, ang imo concern is that uno na parameters ang yaon. So t naught 0, not really a big problem. So ang r naught nimo we have r naught. So we have r naught here. We have v naught. We have the acceleration. Okay. By the way, this is not t naught. This is additional t naught. So we cannot check that one. And t naught is the starting point. Starting time. Yeah, basically. Yeah. So let's check ano yung pwede natin magamit. So ang unknown, ano ganin unknown? Sa letter A, unknown is the v. So this is the unknown. This is the unknown parameter. Let's check na ano yung pwede natin magamit. Okay. So there are 2 equations. There are 3 equations na concern nato. So if you check, na siya v naught, na siya acceleration. However, ini ang problem. This one, nagamit na to pero we don't have the time parameter t. Okay. But the last one we don't have this. And also obviously wala ta ni. Last one wala tay r. Let's see, gawin na nato pag-solve. Okay. Ah, so you use the first equation. Why is that? Do we have the t? Ah, yeah. We have the t. I'm sorry, guys. You have the t there. Ang t is ang part sa given sa question letter A. So we use the first equation. So we have v is equal to v naught plus at. So v man ang unknown. So substituting v naught nimo, which is 2 meter per second I hat minus 9 meter per second j hat plus 80 4 meter second squared I hat plus 3 meter second squared j hat times the given sa problem, which is 2 seconds. Okay. So ang square diri will be cancel siya because of the seconds here. Okay, over man siya. So basically the first two terms the same. Then this one ang third of 4. So 2 times 4 becomes 8. 2 times 3 becomes 6. So I have 8 plus 2. This becomes 10 meter per second I have. And negative 9 plus 6 is equal to negative 3 meter per second j hat. So this is your velocity at time t equal to 2 seconds. Okay. The next one is find the position vector at t equal to 4 seconds. Give the magnitude and direction. So let's go back again. So let me clear this one. So again, ang unknown, find the position vector. So these are the equations na of concern. So we have R naught. Obviously, we have R naught. We have V naught. And we have what else? We have the time. And we have the time. So we have that, this. We cannot use this one unknown, so that means we can use kanisha. We also have the acceleration. So meaning kanisha ang mo-fit na equation because it contains the given and the unknowns. And unknowns, not unknowns, the unknown, which is an position R. This one. Okay, let's go. So using that equation, we substitute the values. But first, we transpose ang kaning negative R naught to the other side, so it becomes a positive. So R naught, if you remember, is 4 meter I hat plus 3 meter j hat plus, kanina yun siya, ang V naught nimo 2 meter per second minus 9 meter per second times the time t, 4 seconds, plus 1/2 acceleration na vector is 4 meter per second squared plus 3 meter per second squared times 4 seconds squared. So substituting. And now adding these, so it becomes 8 plus 32 plus 4. 8 plus 32 gives you 40 plus 4 becomes 44 meters. Then you have the j hat, the y component. So 3 minus 36 plus 24 gives you this value, negative 9 meters. So this is now the position vector at time t equal to 4 seconds. Okay. Yeah, that's it. So I hope you learned something new today. Again, you can email me if na mo yung mga questions, or you can ask your teacher kung dili ako ang teacher. And that's it. Ingat and God bless.